Okay, this video is for our exponential functions in class practice 4.2 number 1. We start comparing linear and exponential functions and coming up with formulas. So the first one says, let P of t be the population of a country in millions. So this is important that you underlined everything you have. So the P of t is the population and it's in millions. T years after 2002. So if you ever see that where I give you a time, that's when we're going to say time is 0. And that's basically our formula is going to start at 2002 and go forward. Then if you can, make some points out of the information that you're given, unless they give you what it is. And it says with P of 7 equals 3.21 and P of 13 is 3.75. So the first thing I'm going to do is make points. So the first point is 7, 3.21. The second point is 13 because that's my input and my output is 3.75. And then I want you to label the crap out of it. So this is years. And remember, it's since 2002. So actually this 7 is 2009 and this 13 is 2015. It makes our formula cleaner, neater, and not as big numbers, okay? And then this is in millions of people. So I label the crap out of it, all right? Now, they first want us to find a formula, assuming it's linear, okay? So I say, okay, y equals b plus mx. I'm going to look at my data points here, my 7, 3.21, and my 13, 3.75, and I'm going to do the slope first because I need to do the slope and the y-intercept, or my b, my initial value. So I'm going to go bottom up, so my delta y goes first, 3.75 minus 3.21, all over 13 minus 7. And when I put that in my calculator, I get 0.54 over 6, or 0.09. Now, the cool thing about this, you already know the units, because right here, this is my y, so this is millions. Remember? And if it purrs and it's not a kitten, it's a rate, and that line means per, and this is year. So it's 0.09 million people per year. So that's, and it's positive, so I know it's growing. All right, now I got to find my b. So now I know y equals b plus 0.09x. And then you can plug in any of the points you want to. And I actually plugged in the 7, 3.21. So I got 3.21 equals b plus 0.09 times 7. Multiply these two and subtract it from the 3.21. So when I do that, my b comes out to be 2.58. And they want us to use P's and T's. So P's and T's. So I'm going to do my population is 2.58 million, and it's growing 0.09 million people per year. So it says describe in words. I just kind of did. So let's say that again. The population of this country was 2.58 million people when? In 2002. And it's growing 0.09 million people per year. So make sure that you're able to do that and describe what you come out to be in real life terms. Okay, the B part here says, all right, we're going to take the same data we have here, the same 2 points, and now I want you to assume the growth is exponential. So I'm going to go and say y equals ab to the x. Now, the one thing I don't want you to do is I always want you to go back to your original data points right up here. Don't use anything here in the green, because that's what you came up with, assuming it's linear. And remember, you can find an equation for linear or exponential with 2 points. And for you to figure out which one's the best one, you would need at least one more data point to see which one would be the best fit. So I'm going to take those 2 points that are above there, and I'm going to, after I stack and rack them, I'm going to put them in my formula. So I'm going to start out with the 3.75. So I have 3.75 equals ab to the 13. So I use that first point. Make sure you do the divide because you have a ratio. Then I'm going to put the 3.21 point in there is ab to the 7th. By doing that, I can say thanks for playing for the a's. My b's are now the same base, and I can subtract my exponents. So I have b to the 6 equals this formula, this ratio here. Now, the one thing I don't want you to do is to put that in decimal form. Just leave it the way it is. And now, in order for me to solve it, I have to raise it to the reciprocal. So I'm going to raise it to the 1/6 because I want b to the first. And I have to do both sides. Now, I do want you to know is you could put the points in opposite, like this could be on top and this could be on top, and you'd get a b to the -6 and raise it to the -1/6. You would get the same. So don't think that you have to do it the same way. So now I have b, and you want to go at least 4 decimal places for accuracy, is 0.0263. Now I know y equals a 1.0263 to the x. Then I'm going to plug in one of my points. I picked the 3.21 and the 7, but you could do whatever you want to do. So I said, okay, y is 3.21 while x is 7. So I'm going to plug it in those spots. And then these are hooked by multiplication. So my a is going to be the 3.21 divided by the 1.0263 raised to the 7th power, and that comes out to be about 2.68. All right. So now I know my formula is, and I'm going to use actual the P's and T's. So my population, in this case, it began with 2.68 million people, and it's growing. Remember, this is my growth factor, 2.63% per year. So this one is a little bit different. This one shows that it started a little higher, okay? And it's growing by, you remember, get rid of the 1, and I'm glad it's over 1 because it's growing, so it'd be 2.63% per year. So now I just found 2 formulas that could be with those data points. And only, like I said before, if we were to get another point or more information, we could figure out which one was the best fit for that population. But I also told the class, more often than not, the exponential one is more accurate because populations usually are exponential in growth and decay because people have babies and babies have babies, and so it grows quickly. Okay, the second one, and this is an actual true story. It says Mrs. Pond bought a new Dodge Durango in 2000. Again, that's time is 0. That's when I bought it. It's brand new. In 2002, the vehicle was worth $19,750. So I say to myself, okay, Mrs. Pond wants me to do points. The amount of money that's worth is based on the year. So my input is my year, and I'm going to use a 2 because 2002 is 2 years after 2000. My time is 0, and my vehicle was worth $19,750. So this is years since 2000. I'm kind of writing on my next thing here, and this is money. Then they said in 2004, so that's a 4, the vehicle was worth $11,250. Now this is true with vehicle purchases. It's called a depreciating asset, so it reduces in value yearly, monthly. And in fact, people say as soon as you drive it off the lot, it's worth less, not worthless, but worth less than what you paid for it. So now they say assume our formula, we're going to find our formula, assume that it's linear with respect to time. Well, before I even do this, because I'm not a robot, I look at it, I see that it's decreasing in value. So if that's the case, my m should be negative, my slope should be negative, or my rate of change. My b, I have no idea what I paid for it, but I do know how much later. So I've got to figure out what my b is, or my initial value. First, I'm going to do the slope. So the slope is, I'm going to go top down because that's larger, is 19,750 because it's delta y all over delta x. And so you have to go the same way. And when I do that, I get negative 4,250. Now remember what I told you, this is dollars. If it purrs and it's not a kitten, it's a rate per, and this is my year. So this decreases $4,250 per year. Okay, that's my unit. And I'm trying to get you used to doing that so you understand in real life what that means. Now I have to find my initial value, or what I paid for it. So I say y equals b minus 4,250 per year. And then I'm going to plug in one of the points. It doesn't matter which one you pick. Let's pick the 11,250. Doesn't matter. So 11,250 is my y equals b minus 4,250 times 4. Multiply those two together. and add them to the other side because you're trying to solve for B. And when I do, I get 28,250. Now, I knew that had to be more than this because remember, it's decreasing every year. So that's my B. So I'm going to write this, what they want us to use, V's and T's. So I'm going to do V, the value of my vehicle, began at $28,250 in 2000. So that's what I paid for it, according to this model, minus $4,250 per year. So I will ask you on quizzes, could you explain to me what that means in words? Okay? All right. This last part is, it says, or one of them next to the last, I should say, is now they want me to find, you guessed it, exponential. So I'm going to say y equals ab to the x. I still have my 2 points. I actually use the 2 19,750 first because it's larger. So 19,750 equals ab squared, divide. Then my other point was 4 11,250, so 11,250. A, B to the fourth. Now here, I see this is here. When I do this, I'm going to say, oh, thanks for playing. And I wanted to show you this way is I have now a B to the negative 2. That's okay. Equals this fraction. That's all right. And leave it this way. Don't reduce it. You don't have to do anything to it. Don't waste your time. Now remember, you want to know what B is, not B to anything else. So you have to make it B to the first. So I have to do the reciprocal and you have to negate it so that I get a positive 1. So that's what this side would be. Remember, you could have put this point in the other way and had the B to the fourth on top. That means this would have been switched and then you would have it would have been raised to the positive 1/2. It doesn't matter. Okay, when I do this, I get B to B 0.7547, okay, which I thought would be between 0 and 1. And as I was doing this in class, I go, you guys can kind of guess that because it's decreasing. So my B should be between 0 and 1. So Y equals A, and go at least 4 decimal places for accuracy for your A to the X. Now I plugged in a point and I picked the 2 19,750. You can pick whatever you want, but that's the one I picked. Equals A 0.7547 squared. It's hooked to the A by multiplication, so I'm going to divide both sides by that. So when I do this, I got A to be 34,675. I didn't do cents. I just rounded it to dollars. So now I want to do the value of this vehicle, the value of this equation. Said I purchased this in 2000 for 34,675, and whoops, there's no minus sign there. And then I'm multiplying this by, because it's B, 0.7547 to the T. So there is my formula. Now, the reason why I put your decimal there is because I want to show you this. This shows that 75.47% is left. So if I was describing this in words, I would actually have to subtract 1 minus my 0.7547 to get a number and then move your decimal place to show you how much it decreased every year. So it decreases almost 25% per year, not quite, but that's how you describe it, that I purchased it. Now, I'm going to tell you right now, I didn't buy it for that much, but it's closer than this is. And you would say that I purchased it in 2000 for 34,675, and it's decreasing. I think it's 24 point something percent per year. Okay, now it says according to each of these formulas, how much will it be in 2006? So you just basically take both formulas and you just plug in 2006. So I'm going to plug a 6 in there. So I've got my first formula, my linear one. And I'm going to throw a 6 in there. When I do the value of my vehicle after 6 years, or 2006, would be 2,750. If I throw it in this one right here, the 34,675, and I throw a 6 in there, okay, 670, whoops, I changed colors here, 675, then what I'm going to do then is I'm going to then plug in a 6 here when I plug it in this formula. So I'm going to plug a 6 here, and this will tell me my value is $6,407.14. So out of the two models in 2006, I'd much rather have the exponential model because it's worth more. And the other thing I want to remind you is exponential functions never reach 0. So this actually will decrease, but not quite as fast as a linear, because after a while, the linear function will say the vehicle is worth nothing. So that's it for this video.